Hello and welcome to GrossiMath.com, where math is for everyone. Today we're going to solve question 10 from the 2017 Algebra 1 STAAR by hand. So let's get started. Okay, so before we even start this video, there are a couple of things about which you need to know. Number one, you need to know what a parent function is. We're going to use that in this video. We're also going to use, number two, vertex form. Okay, and that's going to help us quite a bit. And we can also use, and in order to use vertex form, we're going to change something from standard form to vertex form. Okay, so if you've never heard of vertex form or standard form or a parent function, stay tuned because we're going to review those important concepts. So what is the purpose of this video? Okay, today we're going to take a look at the graph of a quadratic function, which is shown on this grid. And we're going to try to figure out which of these functions best represents this graph. Okay, so the first thing I need to do is understand what is a parent function. So number one, we're going to take a little bit of notes about a parent function. Okay, so a parent function for a quadratic looks like this. F of x equals x squared. And the main thing that you need to understand about a parent function is that if you graph it, this function will create a quadratic that looks like this. Okay, maybe I'll make it be blue so that it can be obvious to you. Okay, now, excuse me, if I take a number and I just tag it on the end here, like let's say minus c to the parent function, what will that do to my graph? Well, if I just tag a constant number at the end, like subtracting it, it'll actually move my graph down because subtracting will move all the values down. And it'll move it down by the exact amount that you subtract. So for example, this graph would move down here. Well, how much did it move? Well, from here to here would be exactly the number c. So you're just going to count squares, basically, or count units, and it would move down by the amount c. Well, what if I add? If I add, it would have moved it up by the amount c. And c can be any number that you choose. However far you want to move it, that's what you set the dial, basically, and it'll move it for you. Okay, so now let's take a look at another one. Well, what if I had it like this? F of x equals, and instead let's put the x in parentheses this time, and we'll put a little squared up there. Well, this is still f of x squared, so my graph would still look like this. Okay, and it's going to come down, touch the origin, and go right back up. That is the parent function graph. F of x squared always looks like that. Okay, and now if I take, let's say, the color brown, and I add c inside the parentheses, you see now it's affecting the square. It's not just at the end. See, here the square was in the front. Here the parentheses means that it's affecting the letter x. So that means, well, it's going to move it to the left or to the right. Okay, well, when I add, if you put a plus sign in the parentheses, it moves it to the left. And how much did it move it to the left? Yes, you guessed it. It moved it by c. That's the exact amount that it moved to the left. Well, what if I put a minus sign? Well, if I put a minus sign, it's going to move it to the right. Okay, so that's how you graph a quadratic function. Now, what you can see here is that what's very important in this problem is, just to review one more time, very, very quickly, what we just went over. If I'm adding something at the very end, it moves the graph up and down. If I'm adding something inside the parentheses, then it moves the graph to the left and to the right. So what I really need is for all of my equations to have those parentheses. And in order for them to all have those parentheses, so now we've reviewed what a parent function is and how they transform, in order to always make sure that I have these very important parentheses right here, I'm going to use something called vertex form. Vertex form basically looks like this. We take the function, there's some parentheses, squared, the x is in there, and then over here we have some number following up. Okay, plus c, or it could be minus c. It doesn't matter. Okay, and here we're going to have, or let's call it k actually, and then we'll put here plus or minus, let's say h. Okay, and that is what it looks like. Okay, actually this should say minus h. Sorry. Okay, minus h and plus k. Okay, so that's probably how most of you have seen vertex form at school. If you have not seen it, this is how it should have looked when you learned it at school. Okay. Oh, and in front there could be this letter a, but we're not too concerned about the a right now. Okay, so look at how many of my functions here are in vertex form. Look at that guy, and that guy. All have the parentheses I was talking about. So a number, parentheses, my variable, another number, and then a number following it. So remember, this guy right here is the number that would move it up and down, and this guy right here is the number that's going to move it left and right. So again, this guy moves it up and down, this guy moves it left and right. Okay? All right, so let's get rid of that to clean it up a little bit. Okay, so now that I have my three choices that are in vertex form, I can look closer at this one and see, well, by this one, it's not in vertex form. Look, it does not have the parentheses. It has a linear term in the middle here, meaning a term with no exponent, and it just is not very friendly in terms of vertex form. So for this one, what we'll try is some substitution if we need it. Okay. There are other ways of doing it. You could have done a method called completing the square, but to be honest, that would probably make this video approximately 10 minutes longer, and I don't want to do that to you. I'm just going to try plugging in some numbers. Okay, so let's take a look at our choices here and see what we get. All right, so the first thing I can see is that the parent function would have passed through here. Okay, and there's the origin right there. Now for what we want to see, okay, and remember that parent function would have looked like this. F of x equals a number, okay, with parentheses, and then x, and then a number, and then a squared outside, and then another number here to move it up and down. So how much did it move down? Well, it moved down by 1, 2, 3, 4. And that brought us straight to this point right here. You see, so this vertex just moved down by 4. Well, if it moved down by 4, the final number at the end would be minus 4. Okay, so right away I can eliminate two choices right here. This guy and this guy. Okay, now what I need to do is take a closer look at this one. Okay, so what would happen? What happened here? Let's do it with brown. How far did it move to the right? Well, it moved 1, 2, 3. And that's my new point right there. And that is how far the vertex moved to the right. So it moved down by 4 and 3 to the right. And that is how it got to be here. Okay, so here I see 3 units that it moved to the right. And that is what I'm going to put here. But remember, if you add a number, it moves to the left. If you subtract a number, it moves to the right. So this should have said minus 3. Okay. Now, if that says minus 3, okay. Well, guess what? This one says minus 4. So right away, look, the reason I kept this one around to begin with was because it had the minus 4, and that is here. But now I'm matching and I see, hey, look at this, minus 3. And guess what? This one says minus 4. So that means that this one is also out. So by elimination, I can already tell that the answer is going to be B, but let's pretend that you're the kind of person who just wants to make 100% sure. Well, what could you do? You could put in some numbers, okay? That's probably the shortest path to a good answer here. So I know the answer is B now. I've eliminated all my other possible choices. And then on this one, we said we would check it with substitution if we needed to, so we can. This point right here, and I'll erase some of my writings there so you can see more clearly, is 3, comma, negative 4. Okay, so if I put that in there and it matches, that sounds like a good look. And let's see what else we could put in there. Let's look for another good point. Maybe we'll put in 4. That looks like a nice flush point. 4 and negative 2. And if we have both of those points on there, I'm feeling pretty confident that this is definitely a correct answer. So let's try it. Let's put in 3. So we're going to put in the number 3 for G. So this is a separate problem now. Now all I'm doing is taking the number 3 and putting it in for G. Okay, and that means that I'm going to get, let's see, 2 times 9 minus 12 times 3 plus 14, and that's going to make 18 minus 36 plus 14. And that's going to make 18 minus 36 makes negative 18 plus 14, which is going to give me a final answer of negative, whoops, 14, negative 4. Whoops. And there you go. So the number 3 as an input produced the number 4 as an output. And guess what? That is a perfect, or negative 4 as an output. That is a perfect match. Okay, so now we can try with one more point just to double check and make sure. And I'll do it again with green. And we'll take out those 3's and we'll put in a different number. Okay, so let's make some space here. So the first point checked. Let's check the second point. 4, 4. Okay, 4 times 4 makes 16, and that's going to be a 4 again. And then 2 times 16 is 32, minus 12 times 4 is 48, plus 14. And then 32 minus 48 is going to make me a negative 16 plus 14, which is going to result in negative 2. And that means that when I put in, whoops, I forgot that 4 right there. When I put in a positive 4, I got out a negative 2. And guess what? That's a perfect match. Okay, so this point checked and this point checked. So this does definitely my answer. Now there's another method that you could have used called completing the square. Again, I didn't want to show that method because I feel like it would have made this video a lot longer than it needed to be. Okay, so today we reviewed what is a parent function. We reviewed the vertex form of a function, and we reviewed how to move the function around. The most critical knowledge of this video is probably that at the end, the constant can move it up or down by adding and subtracting. Adding moves up, subtracting moves down. Inside the parentheses, plus moves it to the left, and minus moves it to the right. Okay, so it's kind of the opposite of what you would think. So that one takes a little practice and just learning it and remembering, oh, it's the opposite of what I usually think. So plus moves it to the left, minus moves it to the right. And you can see that I was able to eliminate A, C, and D, and then just to double check, I plugged in some numbers and I was able to get a final answer here. So that's how you would do this problem with no calculator. All right, I hope you learned something today. Thank you for watching this video. Don't forget to like and subscribe and to click the bell icon. And of course to visit the website where math is for everyone, www.grossimath.com. Have a great day, guys. Bye.